Welcome back to my YouTube channel, guys. So in this video, we'll be looking at questions that can come in this nature. For what value or values of key will a quadratic equation have either two distinct real roots or two equal real roots or two imaginary roots? Right? We've established this in our previous video that um quadratic equation always have two roots. So it's either two real roots or two equal roots or imaginary roots. So now to when you have value of k, for example, you have a a equation like a equation like this whereby you have ax, this is the normal quadratic equation, whereby you are now giving an unknown. Let's say either b or c is now our k. It's just k here is just representing our unknown. Unknown. Let's say for example you have a ax. Let's say no. Let's say 2x squared plus, let's say kx plus 3. So what values or value of k will make this our root a two distinct roots, two real roots, and two imaginary roots. For two distinct roots and two imaginary roots, in our previous video, I told you that for real roots, in order to get a real root, you have your our discriminant now. Our discriminant in previous video, we have discriminant has to be greater than 0. For two equal root, discriminant has to be equals to 0, and our imaginary d has to be less than 0. And we've established that our d is what? B squared minus 4ac, right? So why I said values or values in a situation in when you have greater than, our result tends to inequalities, that is you are giving range of values that can actually make k a distinct number. So you can have, let's say, from -6 less than 6. So from -6 to 6, any value in between, if it's 1 and substitute it here, you have a distinct and real root. So let's have some examples. We'll use a general example, then I'll do another video where we'll use different examples. For example, if you have equation x squared plus kx plus 6 equals 0, right? Let's just put it all around. Plus kx plus 6 equals 0, x squared plus kx plus 6 equals 0. So, and we've established that for you to have two distinct roots, that is, you have d has to be greater than 0, and what's our d is what? D is equals to b squared minus 4ac, and a is 1, a is 1, b is k, that's our coefficient, and c is 6. So d has to be greater than 0. Then we have b squared minus 4ac greater than 0. So you have k squared minus 4a greater than 0. So you have k squared to give us minus 24. I think I missed a step. No. Yeah. Yeah, greater than 0. So k square minus 4 greater than 0, right? So we can take this to the other side. You have k square equals is greater than 24, right? So taking the square root of both sides, you have square root of both sides. You have k square greater than, okay, sorry, square is not gone. You have plus or minus 24, right? So k is greater than plus or minus square root of 24. You can also be written as k square root of plus 12 root of 2 root 6, or to decimal approximately 4.9. That's plus or minus 4.9. So we write this in a range, that is minus 2.6 that is whenever you have anything in this range, any number greater than 2.6, that is from 3 upwards, or if you turn the other way around, that is k is any number in this range. If you put it back into this, you have a quadratic, two distinct real roots. So using the same example, we already established that b square 4 is equal to 0. So just jump on it and just change the change this to equals to. So you have k square 4 open bracket 6 equals to 0. So k square equals to minus 24 equals to 0. K square equals to 4 equals 24. That's 24. So you take the square root of both sides now. You have the same answer as this. So 2 over 6, that's plus or minus the same, or approximately plus or minus 4.9. So when you have this, so here we have a range of values, but for here we have k is either plus 22 root 6 or minus 2 root 6. So any of these values will give us two equal roots, two real equal roots. Why this will give us a range? Any number that is greater than this and the other way around as well will give you two real discrete numbers. So when you have two imaginary roots, we obviously just give us an opposite of this. So let's just do the example starting from here. So let's change this to, just have k square to 4. Instead of greater than, I have less than 0 now. So you just have k square less than 24, square root of both sides. This is a plus or minus. You have k square less than so minus of 2 root 6, right? So you have now the range, it seems as approximately 4. So you have a range of k less than 2 root 6 and minus 2 root 6, right? Sorry, no decimal. 2 root 6. So yeah, any value greater than, so for example you can pick 3 here, but here you can't use 3, you can only use, let's say you can use 2 here to give us two imaginary roots. When we put it back into this and solve it, you can also try it out and find out. Thank you very much.